Okay, good evening, everybody. My name is Jim Wades from Radio Relay International. Tonight's course is TR009. It's entitled Designing an Emergency Communications Exercise. So tonight we're going to talk about some of the broader concepts of how an emergency management exercise is structured and its purpose and the evaluation methods. But more importantly, we're going to talk about how some of these concepts are applied to the amateur radio service. I've had the fortune or misfortune to design a large variety of emergency management exercises over the years, and in many cases, these emergency management exercises have incorporated amateur radio to one extent or another. So I've had the opportunity to see the role of radio amateurs from both the radio amateur perspective as well as from, let's call it, the professional or emergency management side. And what I have kind of discovered over the years is that radio amateurs within these contexts of exercises are very good at testing connectivity, but quite frankly, very poor at testing communications. And we're going to talk about that tonight in the training class. And I'm hoping that each of you could take something back to your Oxcom group, your ARES group, RACES, whatever your local MCOM organization is called, and apply some of these principles to your own local activities. The model for this class is the Cascadia Rising exercise, which took place in 2016. And this was a large-scale federal exercise that involved primarily the Pacific Northwest. And we talk about how we evaluated amateur radio resources as a component in that exercise. So I'm going to start by sharing the screen, and we'll get right down to business so we don't keep you guys here too late. Okay, so let's do this. Let's get rid of this guy here. Let's see, I think that's the one I want to get rid of. No, I got rid of the wrong one, I think. There we go. Okay, so let's start from the beginning. So again, the basis for this class is really how we went about designing an emergency communications exercise for the Cascadia Rising event. But in the broader context, you can take these ideas and concepts and essentially apply them, adjust them to your own local MCOM or activities. And so let's talk a little bit about Cascadia Rising. It took place in June of 2016. Again, it was a multi-jurisdiction, local, state, and federal exercise simulating a catastrophic earthquake and tsunami impacting the Pacific Northwest. There were 6,000 participants drawn from local, state, and federal agencies. And as part of the scenario, obviously, simulations included major disruptions to commercial and government telecommunications infrastructure, the power grid, etc. And so originally, the plan for amateur radio was to transmit such situation reports from the disaster area to the FEMA National Response Coordination Center in Washington, D.C. And this original concept did evolve a bit as we got into discussions with FEMA and with various state and local organizations and agencies. And we'll talk a little more about that. In the words of the FEMA disaster communications specialists, their primary interest in amateur radio was testing high-frequency methods. As one individual referred to it, high-frequency radio was the weapon of choice. The administrator was interested in primarily long-haul communications assets, and FEMA wanted essentially an all-RF solution. They saw, of course, the classical values in the amateur radio service, essentially the survivability of high-frequency resources, lack of reliance on, say, for example, choke points in the form of towers and central offices and digital nodes and things of this nature. The fact that radio amateurs are essentially decentralized as well as dispersed in any typical disaster area. And of course, in at least the specific case of high frequency radio, a degree of immunity to topographical problems. So again, one of the criteria was, all radio frequency, no reliance on the internet, public switch telephone network, or other distributed infrastructure. And of course, the exercise should be mode neutral. In other words, it should test various modes in a manner that leads to interoperability. And again, as previously mentioned, the primary role, at least in the case of this exercise, was establishing long-haul communications capabilities between the Pacific Northwest and the National Response Coordination Center. So Craig Fugate went to the Eastern Area Chair of the National Traffic System, and he asked if NTS would be willing to play this role in this federal exercise. The main reason being is that there's standardized procedures throughout North America. The universal radiogram format provided superior accountability and network management tools, including rules for message prioritization, etc. Basically, unified national level management structure was in place, and there was interoperability between modes and networks, and in particular, both digital as well as common denominator modes. And again, the idea was that this would compare the function of various modes in a disaster situation, as well as the capabilities of personnel in the networks themselves. So again, testing the reliability of high-frequency radio communications and amateur radio assets to maintain connectivity across a broad range of RF conditions. And then, of course, test the ability to respond to a national response plan. Now, a couple of points here. I became the guy who was responsible for designing the exercise. And in discussions with the defense contractor that was responsible for this, essentially designing this exercise, it was my recommendation that we structured the exercise in such a way that it lasted over several days, not necessarily continuously, but we broke the exercise into 3 phases. And the idea was that these 3 phases would each occur during a different set of propagation conditions. For example, one phase in, say, the morning to early afternoon hours, another phase in the late afternoon to early evening hours, and then nighttime conditions. As I've mentioned in other courses, radio amateurs often feel that their capabilities are sufficient to provide disaster and emergency communications because they maybe participate in POTA and they set up a QRP radio in the park. And it's true, they can communicate with a whole bunch of people, right? Some with very good signal reports. But in this particular environment, you are testing or essentially communicating with points or locations that propagation favors. Not necessarily are you communicating with networks or locations that you have to communicate with for an overriding reason, such as establishing emergency communications. So casual amateur operating is really not a test of the ability of the radio amateur to establish field communications or disaster response communications. Rather, in a disaster situation, you have to be able to establish communications with the points that your served agencies require. And they may or may not be in a favorable location that's suitable to whatever the gods of the ionosphere are asking you to accept. So we broke the exercise down essentially into 3 phases to test, a variety of different propagation conditions. And looking at supporting this, one of the questions that I asked is if there were any antecedents to the amateur radio services concept of a plan. So in emergency management, you first have to have your emergency plan or emergency action guidelines, or essentially you need a plan that defines roles, responsibilities, standard operating procedures, etc. And then you design the exercise to test the plan. And based on the evaluation of that exercise, you look at what worked, what didn't. Then you identify necessary changes and you modify the plan so that it becomes increasingly relevant with each emergency communication or each emergency management exercise. Interestingly, neither the ARRL nor any other organization had actually developed a national response plan. No such animal existed. We were unable to find anything going back to like the civil defense era. The closest thing we could find were some FEMA documents that used to be published on communications procedures. So the first step in developing this communications exercises, we needed to have a response plan. So we developed a prototype National Emergency Communications Response Plan, and we used that to as the model for how we would manage this disaster exercise. And then we developed the exercise methodology and the evaluation process to test that plan. So the very first step really in all of this was to identify the scope of the exercise, look at the plan, because no plan existed. We had to create a plan. And then we could go ahead and look at the relative performance of the various networks within the system. And essentially, the deliverables are timeliness, accuracy, and generally operator performance. Again, in the professional world, emergency management or plans have, or exercises, I'm sorry, emergency exercises have to be realistic, they have to be attainable, and they have to be measurable, okay? You need objective measures of performance. And in the case of communications, this generally means timeliness, that is, the network propagation time, that is how long it takes a message to propagate from point A to point B within a network, accuracy, and then generally the ability of the operator to perform the necessary administrative functions. Now, one of the big problems that you will see with radio amateurs in let's call it the real world is they really lack the ability to apply, not always, many lack the ability to apply the administrative tools that are needed to function well in an emergency operations center or a message center or the like. That means keeping a file of all messages transmitted and received, cataloging messages originated by message serial number so you can quickly reference them when inquiries come from a served agency official, the ability to keep a radio log with proper temporal context, that is the time of each communications and a summary of the content. The ability to, for example, if you transmit a message on behalf of a served agency official, noting to whom it was transmitted, at what time, and maintaining that, let's call it administrative, let's call it chain of custody information that protects both the radio amateur and the agency. So what we wanted to do is we wanted a plan that tested these three things: timeliness, accuracy, and the ability of the operators to perform basic administrative functions associated with handling important communications traffic. Okay, so that was the basis or the foundation for the exercise. Now, again, in the broader context, I want to state that the fact that you can establish connectivity is not a sufficient measure of your ability to support an emergency management operation. And this goes not just for hams, but quite frankly, any kind of, dispatch system or, public safety answering point, right? Connectivity is just a little piece of the communications puzzle. Communications, on the other hand, is literally the ability to take information, place it within a certain context, or a construct, if you will, and then transmit that information through a network. And then the person at the other end receives it and then acts on it appropriately. So there's an entire process of communications. The middle part is your connectivity, right? But that's only one piece of it. So do not confuse connectivity with communications. They're two totally different things. And so within the process of putting together this plan and then testing it, we utilized the assets of the national traffic system. And I think everybody here has heard of the national traffic system, at least as it stood before, say 2016, 2017. And this remains pretty much the structure. It's just a question of who manages what. But essentially, it's an inverted pyramid type concept, right? So you have state nets, for example, or often called section nets. You have local nets at the bottom of the pyramid. As you move up this inverted pyramid, you have state or section nets. And then, of course, as you move out of the state, you have region networks. For example, this is the 9th region net, this is the 8th region net, and so forth. And these networks, these region nets, provide for the exchange of message traffic between the states within the region, right? Traffic that is moving outside of that region moves to the area net. So, for example, eastern area or central area here, or western area. And then, of course, there's an overarching long distance top of the pyramid, which is IATN, or the Inter-Area Traffic Network. And of course, I'm not going to go into great detail on this because we discussed this in training class TR002, Introduction to the RRI traffic system. But again, the idea here is that we have this kind of day-to-day routine configuration of the national traffic system, or even RRI nets, in which traffic essentially moves up and down this pyramid, or if necessary, across country between areas via IATN. And this works very well for this like routine casual traffic, kind of the enjoyment people get out of traffic handling in nets, but it's not real well suited to disaster communications. The reason for that is that these nets are time sequence. They operate in a time domain construct. So for example, if you look at, the state nets, for example, in cycle 4 might meet at 7 p.m. The region nets might meet at 7:45. Central area network may meet at 8:30 p.m. Then again, for incoming traffic, the region nets meet again at 9:30, and then the state nets maybe meet at 10, and local nets may meet after that. So if I want to send a message, say, through a region network, and I inject it into a state level net, I might do that at 7 p.m., but it might not get to a state another state within that region until 9:30 due to this time domain construct. So what we had to do in developing the National Response Plan was look at ways we could reconfigure these NTS assets and networks to support an operation outside of this kind of time domain context, this temporal context, because let's face it, emergency and priority traffic, you don't want them to arrive an hour or two later necessarily. They're usually significant to an effective emergency management response, or NIMS function. So obviously we needed to come up with something different. This temporal problem is not an issue with the digital traffic network, generally speaking. RRI operates a digital traffic network. This is a modified hybrid mesh network that's built on Pactor and Vero methods. The nodes and the network essentially function 24 hours per day. It's an all RF based network. And generally speaking, when you connect to a DTN node and you list traffic for, say, any place within the network, the forwarding process begins automatically, right? It's an automated hybrid mesh network. So you don't have these temporal delays in the digital traffic network. That having been said, most interface between the digital traffic network and state or section level nets is done by the digital traffic station. That is a liaison station. So you still need an emergency plan to define the gateway process between the state and the state or section nets and the digital traffic network. You can't have, for example, a priority message, propagate through the DTN very quickly, only to find out that the DTS isn't going to check it until 5 hours later, right? So the plan has to define how often, for example, digital traffic stations connect to the nodes to download traffic for their state, or how often an RRI WinLink gateway operator connects to his node and downloads incoming traffic to his region. So again, this has to be defined in the plan, but the DTN does have this advantage of, at least on the infrastructure side, of being able to forward traffic as soon as it's uploaded, okay? But you still have to manage through directives and a national response plan to define how you handle the transfer process between the DTN nodes and the section and or local nets. Okay, so again, that brings us back to that. So the backbone here is pretty straightforward. We've discussed this in the other training classes, but the main reason I bring it up is that even though all of this is automated, the hubs and so forth, you still have to have a plan that specifies how you manage the gateway and sysop process. There's another aspect that we put into the plan, and that is, in the event of a major emergency, you want the sysop or hub operator to be available, if possible, to monitor throughput so that message traffic isn't delayed by technical problems, right? So there's things that have to be defined, and this, of course, is why you have a plan. But provided you have a plan, provided the technology's there, DTN is a very modern and easily implemented method to handle traffic on a regional or nationwide basis. And so we incorporated DTN as one of the major systems to test during Cascadia Rising. We, of course, also tested what I'm fond of calling common denominator modes, the CW and voice nets, right? The beauty of common denominator modes is, number one, every ham shack has a microphone, or if you happen to have a Morse key, you can plug it into pretty much any transmitter or receiver of pretty much any vintage and transmit and communicate. We discovered that there's some real advantages to common denominator modes. We'll talk about that later in the presentation, versus automated systems, and that is the ability of the operator to dynamically respond to propagation problems, co-channel interference, adjacent channel interference, and the like. And so, and as you'll discover, common denominator modes actually turned out to be the better performer. So the point here being that there's value in all modes. The trick is to allocate those modes in a manner that is best suited to the emergency management function one is trying to support. As we mentioned in the portable operations workshop, if I'm sent out to provide some supplemental communications at a train derailment in the middle of the night on a rainy evening, I might be better off with a handheld radio and a pencil and a set of maybe a big Write and Rain notebook, right? Trying to use a computer, laptop, or printer in that kind of environment can be very difficult. So sometimes you again, the plan has to kind of give some guidelines for how you apply these modes. And you also have to approach modality, you might say, with an open mind rather than what I'm fond of calling parochialism. This is my favorite mode, or digital is always better. So I'm going to stuff this round peg into whatever square hole arises because I have this kind of a prejudice or this parochial view of modes. And what you really discover is, as I've often said, and I'm sure others have, is that a diversity of modes is the key to an effective emergency communications response program. So I'm not going to dig too much into the central and area nets, other than to suggest that when we took a look at the tasking from FEMA, we relied primarily on the state nets within the affected states, the region nets that were again in the next layer of the pyramid above the states area, and then long haul communication circuits. And we repurposed these nets to respond to the disaster based on the prototype plan we had developed. And one of the key components in this, obviously, was the inter-area traffic network, or what we used to call TCC. And the reason for that is we knew there would be a high volume of traffic moving from Alaska, Washington State, Oregon, Northern California, and Idaho to Washington, D.C., right? So we had to have resources in place to take this priority traffic out of the simulated disaster area and move it across the country. And there were generally only two ways to do that, and that was either IATN assets or the DTN. And so in the plan, we created what we now call the priority entry point concept. Establish watch frequencies for priority and emergency traffic for out of state or out of area agencies. And then these circuits and these sysops and gateway stations are responsible for servicing those networks to get the traffic delivered as promptly as possible. In other words, as soon as traffic is listed, it's on its way to its destination. So we, again, established special IATN routings across country from the Pacific Northwest to the National Response Coordination Center. We established watch frequencies spaced between 3 and 30 megahertz, of course, different amateur bands to accommodate different propagation conditions. And these were watch frequencies. That is essentially a group of competent, qualified operators would stand watch on these circuits. And when traffic was moving out of the state or region for the National Response Coordination Center or another location, they could move onto one of these watch frequencies and call for RRI, okay, and basically indicate that they're holding a certain amount of priority traffic. The stations would establish contact on the watch frequency, move to a working frequency, clear the traffic, move it across country, and get it to its destination. So at the state level, you have all your ARIES and Oxcom, RACES traffic going on. NTS nets are supporting that. RACES and ARIES nets are supporting that, etc. At the region net, traffic is moving, say, between Washington and Oregon, or Washington and Idaho, or Washington and Northern California. But traffic that had to specifically go to FEMA, as well as some traffic coming out of Alaska and the like, it was transferred via these watch frequencies, these priority entry point frequencies, primarily on 40, 30, and 20 meters. And this is running, meanwhile, parallel to digital traffic network. We established injection points for the manual modes for both voice and CW. And then, of course, DTN. So operators were at liberty to use whatever net they felt was best on their end, right? And This allowed some advantages. It allows for traffic, or it allows for load distribution, right? If one circuit's busy, you can go to an alternate frequency or an alternate circuit. If you have digital capabilities available, you can go to DTN. If you have only CW or voice capabilities, you can pick one of those networks. Essentially, the idea here is interoperability. You got to have a standardized message format. You have to have the network management tools necessary for servicing messages, tracking messages, knowing who you sent them to, etc. And you want to have the ability to respond dynamically to varying traffic loads and the like. Furthermore, as part of the exercise, we distributed a frequency mode matrix. We purposely did not publish it on the web or distribute it to the broader amateur radio community, just in case somebody decided they wanted to have a little fun disrupting the operation. So we simply distributed it to the operational participants. And then, of course, before we did this, we put together a team that researched possible frequencies to identify those most suitable to a national response. Now, you'll hear hams often, they'll say, we're going to start a net. And they say, okay, well, let's start a net. Well, let's pick a nice crunchy frequency like 7030 or 7045. And what you find out is that they do very little research to find out what that frequency is really being used for and how it's being used. Now, nobody owns a frequency, but what you find is that there's affinity groups that kind of congregate around certain frequencies. There's nets that use them, be it casual nets or traffic nets or Aries nets, whatever. And so before you establish a net, and you select frequencies, maybe a primary, secondary, and alternate, you need to monitor those frequencies for a time. You need to do some research on the web and say, is this a commonly used frequency? For example, if you choose 7050, it's the SKCC, primary frequency, right? You hear a lot of SKCC guys on there. If it's 7033, that's kind of the bug frequency for bug users, etc. But if you can find a frequency that's kind of out of the way and it's just used for casual QSOs, it's likely to be more successful, right? So another advantage of having a mode frequency matrix is that you can identify frequencies by an identifier. So, for example, you can say to a station, move to frequency RCB, Romeo Charlie Bravo, and he can move to that frequency. And if somebody's causing malicious interference, they may have no idea where Romeo Charlie Bravo is. It might be on a different band, it might be a different mode, it might be elsewhere in the spectrum. And so we included that in the exercise. So for the exercise, we established, basically a mode frequency matrix. And so here you can see, frequencies and modes with identifiers here for Washington State, Oregon, Idaho, and Region 7. This is just a snippet of the mode frequency matrix distributed to exercise participants. You might kind of call this it's a little bit like an ICS 205 type, communications plan, but probably closer to what you would see in the armed services, or at least you used to. I don't know if they still do things like that. This is an example of a portion of the mode frequency matrix for DTN. So each exercise participant essentially got a mode frequency matrix, and this defined the watch frequencies, the DTN frequencies, the state and regional frequencies for moving message traffic promptly outside of the typical NTS framework, right? And so, for example, these were the frequencies for the IATN, or what again today we call priority entry points. These are we can activate these watch frequencies, for example, for priority traffic going to a specific state, or coming out of a particular state. So let's say there's a hurricane in Puerto Rico, we could establish priority entry point channels for people to have a qualified operator standing watch on certain frequencies to receive, emergency and priority traffic or welfare traffic or the like. So this can work either way, right? To take traffic out of a disaster area and move it to a specific agency, or or target a particular disaster area to get the traffic out of that area and then distribute it using the best mode available, maybe even commercial services if necessary, the internet or public switch telephone network or the like. So again, for Cascadia Rising, the first thing we did is we developed a national response plan. If your ARES or MCOM group doesn't have a plan how to handle alert and notification and procedures for supporting certain agencies that you deal with regularly, identifying maybe a repeater to be used for check-in and deployment, a repeater to be used or frequencies to be used to support certain key agencies, layering your nets so that you have ideally several nets operating on different frequencies, each with a focused emergency management function to support. You got to have the plan. So the first thing we did is we made sure there was a plan, because one didn't exist, we created it. And then we began to build a packet, if you will, for each exercise participant. And one of the contents in that packet was the mode frequency plan, the mode frequency matrix. So people knew where to go with their routine, welfare, priority, or emergency traffic. Obviously, we were operating in support of FEMA. So in the case of FEMA, we went ahead and we established the long haul circuits using both the IATN manual mode assets and the digital traffic network. And we defined a target station to collect this traffic and then inject it into the web EOC in Pennsylvania. Now, the reason we did that is in this scenario, communication systems are working just fine in the eastern United States, right? But they're not working in the Pacific Northwest. So we used a target station concept. Any traffic coming into the National Response Coordination Center went to the Eastern Pennsylvania section, and they went ahead and they had several operators who were responsible for taking that traffic off of amateur circuits, putting it into web EOC, addressed to the National Response Coordination Center, where the traffic would show up in their data stream along with all the other inputs that are going into their message center and their operational environment. And so we had both, again, CW and voice circuits that were feeding this traffic across country, as well as the digital traffic network, or at the time we called it NTSD. So again, the idea here is you got to have a plan, because a plan is what allows you to, number one, it's like singing from the same hymnal at church. It tells operators what the expectations are, how they're going to support various agencies, what networks, frequencies, etc., are generally assigned to which agency, and it generally organizes the response in a cohesive way. And then when you exercise, you test the plan, right? You test these networks, you see how they work, you see how they're layered, you see how traffic flows and how communications occurs. So again, we want to answer, is connectivity established and maintained? It is important. Are the networks survivable? That is, can they continue to function in different propagation conditions, etc.? Is the network capable of accurately conveying the information provided by the served agency? So for example, a served agency official comes to you and tenders a message for transmission to a another location, you have to have the ability to transmit that accurately. Likewise, the operator on the other end has to have the ability to receive it accurately. And then, of course, again, recording the time it was received, putting it in the message file, doing all the things that go with operating at a message center. And most importantly, you need to have the proper accountability and network management data in place so that the network can operate efficiently, replies can be routed efficiently, etc. Again, most emergency communications groups can only answer the first question, maybe the first two, right? This concept I developed many years ago. I taught a class on disaster telecommunications planning for the Michigan State Police Emergency Management Division, and I developed this as kind of a tool. And we talk about this in the emergency communications planning course. But again, the first and foremost responsibility of HAMS is survivability. We're the communications resource of last resort, so survivability comes first. Flexibility is next in the order of importance because it does you no good if you can send 5 or 10 encyclopedias of information every 30 seconds, unless you can do it from the location where it's needed. Next in order of importance is circuit capacity. You have all the circuit capacity in the world, but if your data circuit, for example, can't be deployed to where it's needed, or it can't survive the impact of disaster, it's not sufficiently hardened, well, circuit capacity doesn't matter. And last but not least, well, I guess last and least, is security. Ham radio operators don't typically operate in the national security environment. They can't encrypt, and at least therefore in the amateur radio service, communication security is not particularly important. And I think sometimes hams overemphasize this. They're very worried about who's listening and things of this nature. The reality is that that's really not our primary concern. Getting the message through is, and there's very little traffic that you're going to handle that has a high security value. There are some things that are sensitive, for example, a casualty report or something of that nature that you might want to send through a network that has a degree of inherent security. CW, VHF single sideband, a digital voice mode, WinLink or whatever. But generally speaking, this is the order of importance. When you test your network, again, we talk about this in another class, we're looking to identify the weak links in the chain, right? The example here I use is like an interlocker in a train control network. If the safety integrity level is the highest safety integrity level for say, for example, the train detection scheme, the vital processor, and the wayside signals that control train movements, that's great. But if somewhere in there I inject components that have a low safety integrity level of like a SIL 1, the whole system is a SIL 1 system, right? So our exercise needs to look for weak points that are failure points and try to identify them. That's what we're looking for, right? We also want to know who's up to the task. Let's be honest. Not every radio amateur is up to the task of providing emergency communications. Some years back, we had a big search and rescue operation going, and quite a few radio amateurs showed up to help, and they were all good guys. But I swear one guy was on the verge of a heart attack out in the field. He was not physically prepared, right, to provide the service. Other radio amateurs simply have no traffic handling experience. You can hear the difference between those that have handled traffic and those who haven't, those that have participated, say, in NTS and those who haven't. There's a striking difference when you listen to voice nets. How often have you heard the lack of circuit discipline? Maybe it's a busy hurricane watch net, and the guy checks in and says, "Yeah, I'm up here in North Dakota. Just want to let you know I'm here in case you need anything. Well, yeah, we definitely need weather data from North Dakota. That's going to really help the hydrological models for this particular hurricane in South Florida. I'm being a little facetious, of course, but the lack of training and so forth, yeah, is a major factor in communications failures with radio amateurs. And so let's talk about that. This is called human factor in industrial hygiene and industrial safety courses, the human factor accidents. Uh, we tend to look at a lot of technology, but many of the failures involve the human interface. For example, you can take a mode like WinLink, where everything is kind of automated and there's automatic error checking in place, etc. But that does not occur at the human input side. Data entry errors, misspellings, improper abbreviations, an error in numbers. It's really a problem when somebody types in a message and sends it via WinLink, okay? And let's say that, he there's a garble. He made a mistake or misunderstood a chemical term, or the name of the medication, or the quantity of items required. So garbage in, garbage out, right? It doesn't matter if it's an automated digital system, a radio telegraph network, or carrier pigeons, right? Lots of misunderstandings related to technical terms. Radio amateurs aren't necessarily medical professionals, or they're not necessarily experts on hazardous materials response. Um, you know, they don't, they may not be law enforcement professionals. There's terminology and so forth that emerge in important message traffic that you have to be able to understand. Doesn't mean that you need to understand the term and its meaning necessarily, but you got to make darn sure that it's spelled correctly and communicated correctly. If somebody says, you know, uh, let's say sublingual salivary gland, you better, ask the served agency official, how do you spell that? Or, clostridial myonecrosis, or acute dilated cardiomyopathy, or weird things like that. 1,2 dimethyl hexane, or, whatever. You're going to possibly encounter these things, right? You're going to have served agency officials that come up to you and ask you questions like, what time did that message come in indicating that the water buffalo was going to be delivered? How many cots were requested for the shelter at Harding Middle School? These kinds of things, you need to be able to go back into your file. You may get a message back that says, Lieutenant Johnson, unavailable, please provide alternate point of contact. You want that reply to refer to a message number, so you don't have to read through 200 or 300 messages to try and figure out which one the respondent is referring to. Okay, so I use this again as an example in the other course. These are 2 aspirins. I've used both of them, but not on myself. The one on the left is an aspirin I've administered to horses. And of course, the 81 milligram aspirin is a baby aspirin, or they're the kind some people take for reasons of cardiac risk. You can see there's a big difference between 15.6 grams and 81 milligrams, right? One missing letter does make a difference. So when we develop an exercise, we have to test this entire communications process, and we want it to be realistic. We want it to be measurable, and we want the exercise to be attainable. It does your group no good to exercise for the zombie apocalypse, or the second coming of our Lord. Make it something that's realistic. Talk to your emergency management agency. They'll probably actually define the realism of the exercise. It should be something that is an actual hazard and or vulnerability in your community or your region, right? right? So you want the exercise to be realistic, people take it more seriously, and your lessons learned will apply to actual hazards in your community. You want it to be measurable, okay? And we'll talk again about how we attained measurable results with Cascadia Rising. And you don't want to set your group up for failure. For the same reason, you should always be honest with your served agencies about what your capabilities are, okay, and not promise more than you can deliver. Your emergency exercise should reflect that philosophy. Your exercise should be designed so that it is attainable based on the resources that you have. Because even that defines the expectations of your, let's call them served agency customers, okay? And again, it doesn't really matter how you get the message there, be it carrier pigeon or high speed a mesh network. What really matters is that you get the message there in a timely manner, or you get it there accurately. Right, time and timeliness and accuracy, and the ability to go back and document and reference information as it's transmitted and received, keeping an accurate radio log. That's the kind of stuff that's important. So let's go into collecting data. So what we did with Cascadia Rising, and you don't necessarily have to do exactly this, but this is to kind of feed your imagination a little bit. We went ahead and we decided to utilize controlled inject messages. So essentially what we did is, well before the exercise, we went ahead and created a large quantity of message traffic. And the idea was that because we knew because the exercise evaluator would have a copy of the message as it was tendered for origination and injected into the network, he could compare that controlled inject message against the message as it appeared in the data stream at the National Response Coordination Center. So you take the original message, of which you have a copy that you knew it was going to be originated at a particular time, and you look at that message. You take the message off the data stream at the National Response Coordination Center, then you compare the two for errors, okay, or missing information, etc. Okay, so that was number one, controlled inject messages, simply an envelope that says open at such and such to hand to the radio operator. And each of these messages, they open it at the given time, they give it to the radio operator injects it into the network, it goes through the whole communications process, comes out the other end, then they collect all those messages in the data stream, and you say, oh, okay, I'm going to compare each of these messages and see how many data points are correct or incorrect, okay? The radio operators participating in the exercise were required to keep a radio log, essentially when the message was injected, and likewise when it was, we already had a timestamp at the National Response Coordination Center, or from whom, if it was relayed, from whom it was received and to whom it was relayed. So every stage that a message moved through that network, if it was point to point of origination, the time at which it was originated versus the time it was delivered. If it was relayed, we had a log for every step in the relay process, so we could identify failure points, okay? And then, of course, this allowed us to define network topology, figure out how messages flowed through the system, etc. So we pre-formatted all of these messages, and we created some guidance documents, which was essentially the prototype emergency plan. And we distributed this to the operators in Alaska, Idaho, Northern California, Oregon, and Washington State. All messages were properly formatted in standard radiogram format, okay? Which basically means it's an ICS 213 with the network management data, message serial number and precedence and a group count or check and time of origin, etc. We decided for the purpose of this exercise to have all the messages placed in 5-letter cipher groups. The reason for that is number one, message content cannot be predicted. Number two, it provides an excellent test of accuracy. And number three, it makes it an easy statistical problem for measuring the accuracy of the radio operators from point of data input to, through the whole relay process. But we did a little more than just have 5-letter cipher groups. Occasional messages would include a 6-letter cipher group. Occasionally a message would have a counterintuitive date-time group. We would put little errors in these messages to see how the radio operators handled them. Would the 6-letter cipher group actually arrive in the message at the National Response Coordination Center? These messages, these pre-formatted messages, were basically placed in an envelope, and they were date time stamped on when they should be originated by the radio operator. So they got basically the operating guidelines, the plan. They got explanation of how to keep their message logs and so forth. They got a complete log and log all their communications traffic. And then, of course, they got their set of messages to be originated during the emergency. And so, they, again, open at such and such a time on such and such a date. Here we're going to talk primarily about our destination. Again, the routes had to be all RF, and this was a grid down scenario to test the ability to move communications traffic across country. You might argue that we gamed the system a little bit because we utilized operators we felt were competent for all of the high-level functions. IATN, moving the traffic across country, used experienced traffic handlers. We wanted people that had the necessary skills. For the same reason that if my house catches fire tonight and I dial 911, I want to have a reasonable expectation that the firefighters that show up outside my house know how to operate the apparatus, know how to ventilate the structure, know how to extricate me if I'm a fire victim, and so forth, right? You don't send the neighborhood watch person to the hostage situation to manage it, right? You send a qualified police officer. Same thing with this. You want your qualified operators to handle the high level functions. Another thing that we incorporated into the exercise was the requirement to know network topology and connectivity. So, for example, you need to know which agencies you have connectivity. For example, a disaster official comes to you and says, look, I need to get a message to Glens Ferry, Idaho. You need to have like an ICS 205 type plan. You need to understand who's on your networks. So you can say, yeah, we have a station in Boise, if that will work, and we can route the traffic to him. That's great. Here's the message. And then you know what frequency, what network, how to route that traffic to that operator. So for the Cascadia Rising exercise and in our emergency plan, we have what's called a network management coordinator. And basically what it is every operator who is active in the disaster operation that's operating in our nets sends an operational readiness report. And this report basically says, I'm operational. I will be operational for these hours. I have liaison to these ARES nets, RACES nets. I have connectivity with these agencies. And these are any special needs that I have. And here's the nets and modes and frequencies on which I can be contacted. That way, the emergency management director can say to an agency official, look, I do have somebody, that can clear that traffic for you and get it to that agency. Or just as importantly, no, we don't have an outlet there. I don't know if I can't assure you that I can get that traffic to its destination. And I've given him an honest answer. So for Cascadia Rising, we had a network management coordinator. His sole job was to be a target station for collecting these operational readiness reports and creating a spreadsheet where you could look and see where each operator was located, and you could identify, well, the agencies with whom or with which he had some kind of connectivity, right? And the frequencies and modes via which you could, in nets via which you could contact them. So that was another thing that we incorporated into the exercise. So that was the network manager's job. And generally speaking, a network manager, network coordinator, you want him to be off-site in a disaster benign area. And his sole job is just to manage this task, right? You don't want him in the EOC, in an EOC. You don't want him in the message center. He's a guy that can do this from anywhere, where he can do it unimpeded by the hustle and bustle of the problems that surround him. It worked out very well in Cascadia Rising. So generally, these two types of messages were transmitted: operational readiness reports and the controlled inject messages. We did not score the operational readiness reports. We only took a qualitative look at them, okay? We did score the controlled inject messages. And and we did two things. We scored them for accuracy, and we scored them for the time it took the message to propagate through the network system from point of origination to point of delivery. And then obviously we made note of any connectivity failures, delays, or significant statistical outliers that we needed to investigate. Okay, so generally speaking, when you're looking at the 5-letter cipher group messages, we treated each letter or figure within the radiograms as a unique data point. Each distinct error, such as an improperly transcribed letter or figure, was graded as a single error. If there were up to 3 errors within different cipher groups, these were treated as individual errors, whereas 4 or more errors within the entire message were treated as a fatal error and the message was discarded. Likewise, 2 errors within a single group, okay, were counted as 5 errors. 3 errors or more within a single group were counted as a fatal error and the message was discarded. Okay, so we used kind of an engineering criteria to grade the performance of the radio operators. So this might be a typical controlled inject message, and there's another sample of how it appeared on the general message form at the National Response Coordination Center in the lower right-hand corner. Okay, and this is a typical log. So you can see here that I think this came from Alaska, but you can see that who it was received from, who it was transmitted to, the date time group associated with each message, etc., etc. And this was every participant kept this radio log as part of the exercise. Okay. Interestingly, Alaska is a very unusual place in terms of communications problems. Those of you that kind of know the history of the Army Signal Corps will know a lot about the difficulties of establishing high-frequency communications with Alaska. And within Alaska, the Ares organization used a backdoor network, but to get the traffic to the United States, it went over a high-speed radio telegraph circuit to the 7th region, where it was received via the IATN operators in CW and then transmitted across country. Again, interoperability between modes because of the unusual propagation conditions associated with with the higher latitudes, let's say. So essentially, here's the accuracy measurements for the communications traffic. The Alaska intra-state backdoor network scored an accuracy rate of 100%. They drill regularly. They have a very proactive section traffic manager and SEC. They did very well. The digital traffic net, in terms of accuracy, scored 99.997% accuracy, and the combined radio telegraph circuits scored an accuracy rate of 99.998%. Interestingly, voice was not used, and the reason for that is propagation conditions were so poor during the 3 periods that we conducted this exercise due to solar storms and unsettled geomagnetic conditions and all that kind of stuff, that nobody could use voice communications. And this, again, very much illustrates the difference between CW and voice methods, or digital methods and voice methods, in a realistic disaster scenario. Let me go back to this one for just a minute. I guess I didn't put it in here, but this score here is 99.998% against approximately 13,000 some odd data points. So that's over 13,000 data points of all the communications traffic over the 3 periods of 2 days. That was 99.998% accuracy. The digital traffic network, let's face it, 7 thousandths is de minimis, so that they basically performed equally well. This was a data input error or two, if I recall, and that was over 8,000 data points. And again, keep that in mind. That's kind of an interesting factor too. The CW net carried more traffic than the digital net. Oops, I don't know how they did that, but message propagation times. Let's talk about that. Somehow I goofed up the program. It jumped ahead on me. For the radio telegraph net, the average message propagation time was 30.5 minutes. However, we did discover a couple of statistical outliers due to human error. For example, one misplaced message resulted in a delay of 110 minutes. If you took out these 2 or so statistical outliers, the average message propagation time for the CW nets, even though they were carrying more traffic than the digital system, averaged between the 10 to 15 minute range, approximately 13 minutes. One message was measured at 1 minute from the time it was originated in Washington State to the time it appeared in the data stream. Not bad for a CW operator. The Alaska Interstate Net, again, 100%. We didn't measure the time except from the time the traffic left the state to the time it got to Washington, D.C. Because of this 2,000 mile long circuit. So we kind of ran the Alaska Interstate tests separately. And then, of course, then the second phase of it, of course, would be the transmission of the traffic via the Gateway Circuit, the CW circuit, to the National Response Coordination Center. The digital traffic network did not perform as well as we had hoped. Average message propagation time for DTN was 82.4 minutes. And the reason for this was the marginal propagation conditions during particularly exercise phase 1 and 3, the daytime functions. Propagation conditions were terrible. And the other problem that DTN experienced was also a problem reported by WinLink users. So many ARIES and MCOM groups were relying on WinLink, and so much of that traffic was stuffed into these narrow automated subbands that there was a lot of delays trying to access nodes. Even though WinLink has all these nodes available, There was so much demand on WinLink in that those narrow slices of spectrum, particularly under poor propagation conditions. It created a problem for both DTN and WinLink. Also, by design, at least for this exercise, we had no attendants present at the DTN hubs. Now, this is another interesting thing that we learned with the difference between the CW nets and DTN. The CW operators are operating in real time. They are an integral part to the process. Manual modes, not just CW, but any manual mode, the operators are at liberty to adjust their frequency, move to alternate frequencies at a moment's notice. They can turn their antennas toward the disaster area if they have a beam. They can flip on an amplifier. They can do some things that are necessary to improve and dynamically respond to interference problems or propagation problems. With these DTN hubs, they typically operate without an amplifier. They use omnidirectional antennas for the obvious reasons. They need to communicate all the time in multiple directions. And one of the things that we took home from the exercise is that we need to have some DTN hubs where we can actually point a beam antenna at a disaster area so that we can improve connectivity, or if necessary, move the DTN hub monitoring frequencies, a couple of them outside of the digital subbands for the duration of the disaster. But as you can see, the average message propagation time, that is the amount of time it took a message to move from the time it was tendered for origination to where it appeared in the data stream, was much higher for the digital traffic network. But these were pretty typical band conditions during phase 1 and 3. You may remember this chart. I think it came from dx.com or one of those kinds of websites. It was really miserable conditions, and that had a lot to do with the reason that single sideband was so difficult that it generally wasn't used, and most of the traffic moved via either the digital traffic net or CW. We did publish a rather extensive report, and this, I believe, is still available on our webpage, where you can actually see the data all laid out here for the FEMA traffic, and it gives the typical propagation times and destination, as well as some notations and the like. So here's the lessons that we learned from this exercise. Radio operator skill and experience is going to be the key to success. We could not have done this exercise without experienced traffic operators. Now, I often hear hams say, well, radiograms are silly, birthday greetings, renew your license, this is just silly stuff. It's not silly, because it's the skills you develop, relaying traffic, receiving traffic, transmitting traffic, etc., that has the value. Every address is different. Names are different. The text is different. You learn the standard radio telephone or CW procedures. You learn how to use DTN. You begin to understand the importance of the network management data in the radiogram preamble. Generally speaking, there's no replacement for an operator who can say, spell an unusual, term, cardiomyopathy. I spell Charlie, Alpha, Romeo, Delta, India, Oscar, Mike, Yankee, etc., etc. This is the important skills, right? And it starts with the communications process. A diversity of modes is essential. If we had relied only on single sideband and we didn't have the CW resources available, we would have performed much more poorly in this disaster operation. Okay. Manual modes still have value. The ability of operators to respond dynamically and often instantaneously to adjacent or co-channel interference or poor propagation conditions. The common denominator methods, again, offer versatility and universal access, particularly at the lower levels, the local and state level of network operations. The DTN was less agile. Uh, Obviously, we learned some lessons that we need greater diversity of hubs with better geographical dispersal. And again, the importance of the SysOp to be able to adjust frequencies in operation to support a major disaster, and the like. But some things worked really good, right? The human element proved important. Most of the traffic handlers who participated in this had some kind of professional background. You have the Army Security Agency, Navy operators, maritime radio operators, or just radio amateurs that had extensive daily experience in message handling. Traffic handlers tend to be pretty good at keeping a file of messages and tracking who they received it from and who they sent it to. And this showed up in the radio logs that everybody was required to keep. Obviously, in a long-term disaster, we would need more more operators and perhaps even some multi-operator facilities. One of the ideas that was suggested, it would be really nice if some of these big contest stations could be, kind of join up with RRI or NTS or ARES and serve, in a disaster, serve as a multi-operator facility or a gateway for getting communications traffic out of a disaster area. And so anyway, the idea, more volunteers, right? So other lessons that we learned, FEMA was very pleased with the radiogram format. They understood its applicability, and they specified it for the exercise. The fact that it does identify not just the basic accountability data of the ICS 213, but the ability to route traffic based on the network topology defined in the preamble. The high-frequency radio networks, again, that's the weapon of choice in the minds of many government officials because of the vulnerability of terrestrial-based systems and satellites and the like. And then, of course, the survivability of the amateur radio service. So again, what I want to stress here in this training is that, sit down and have a plan. We talk about it in the disaster telecommunications planning course. You got to have a plan. The plan becomes your ruler, your caliper, your measuring device, right? That's what you measure your performance by when you do conduct the exercise. Number two, don't confuse connectivity with communications. Communications incorporates connectivity, but connectivity doesn't necessarily incorporate communications. So you have to be able to test the ability of operators to handle traffic. You need to be able to measure their accuracy, and you need to measure the timeliness of how quickly message traffic moves through your communication circuits. Number three, you should test interoperability. As I stress in other courses, you may send a 500-word message easily via WinLink, but when it gets to your message center or your EOC, what happens if that operator's out or that agency official to whom it's addressed is out in the field, and now that message has to be transmitted over a public safety talk group? That's a very laborious and cumbersome process, right? What happens if it's really dire situation, say a major tsunami and a category 9 earthquake, as in Cascadia Rising, and the only operator available has voice communications capabilities? You may originate your message using a high-speed digital method, but you're not thinking necessarily about how he's receiving it. and how that affects the amount of circuit capacity he has available and the amount of time and the amount of traffic that he's dealing with. Brevity is the soul of emergency communications. So understand that. So measuring time and measuring accuracy are two of the things you want to accomplish in your MCOM exercise. Lastly, I would not expect that your typical local ARES or MCOM group would necessarily engage in a process this complex. We put together an exercise that was kind of a professional defense grade statistical model. You don't necessarily have to do that, but you can take some of these ideas home. At the local level, you have the equivalent of the network manager function, right? In the operational readiness report, you have the ICS 205. The guys down in Texas do an excellent job with the ICS 205 and the frequency, the radio communications plans, etc. Make sure you can do those tasks. Make sure that your operators in the message center or the EOC or wherever can keep a good, competent radio log. Examine those, take a look at it. Make sure those administrative tools are in place. Make sure people understand the message formats. Make sure they can adapt to changing situations in your exercise. So those are the big takeaways as far as I'm concerned. I guess at this point, this is a good opportunity to stop the screen share and have a discussion or answer questions or whatever the case might be. So now you can stare at my ugly mug and ask me whatever you want to ask me. So. Thoughts, comments, real world experiences, ideas? Or did I put everybody to sleep? Should I told some funny golf jokes or, something like that?
No, Jim, no, nothing like that.
Okay.
Just as you were going through it, it was just giving me different ideas on how to put together something locally here for the New York City area. That I in the 30 years that I've been doing this between Bayonne and New York City, has been standardized HT repeater, maybe giving a shelter report. But now we need to get more accuracy out of it. Now, while we may not be using HF locally, because hey, signals will skip right over each other's heads, but you still have VHF simplex that you can use. You still have 10 meters for those who have that capability. But I like the idea of the cipher groups, and I've been playing with an idea, maybe taking a meaningful phrase or identification and a serial number, let's say, and encode it in base 64 so that they are just transmitting what seems to be random letters and numbers, but then when you put it through the base 64 decoder on the other side, you've got your string of message.
Yeah, so you can yeah, there's a number of things that you could do. You could send license plate numbers or whatever the case might be. The idea here is, and it doesn't necessarily even have to be cipher groups. I mean, just maybe look at some of the things that ARES groups regularly exercise in at the request of their emergency management agencies. So, for example, hospital nets. Okay, pre-formatted messages with medication requests. We need so much of a particular medication. Pre-formatted messages reporting, ER capacity or trauma center capacity. Pre-formatted messages reporting problems that are occurring at a hospital. Intermittent power outage, generators not starting. You look at the different emergency management functions, and you can come up with a pretty wide variety of measurable messages, particularly things that request quantities of items, particularly items that might be unfamiliar to the rank and file radio amateur. Drugs are a great example. Chemicals releases are an excellent example because the names are difficult and complex. Test those traffic handling skills. Are you really ready to send something unfamiliar or even just unusual surnames? I mean, New York City's a great example. I mean, it's ethnically diverse, right? So send a list of maybe 4 or 5 shelter residents that the agency is looking for, but choose names that are Asian or Eastern European or Middle Eastern or something that people aren't generally familiar with. See how they come out at the other end.
Yeah, it's like the old telephone game when we were kids. See what comes out the other end.
Right, right, exactly. And really, and I've seen this in emergency management exercises, it is like the telephone game. You'd be shocked at how messages get garbled through assumption and so forth. And again, that's the beauty. That's why I'm big on traffic nets because, it may not be important to send a message that, you should renew your amateur license or, thanks for the nice QSO on 20 meters. But every one of those addresses are different. The procedures for spelling, say an unusual surname or an unusual street name apply. The procedure is what becomes kind of muscle memory, so to speak. It utilizes your brain plasticity to remember the procedures needed to spell unfamiliar terms. And so it's practice. And radio amateurs, I think a lot of hymns have a bit of fantasy side to them. They imagine themselves kind of heroically, providing emergency communications resources to their community. But the reality is really much different. Your primary value in 90% of cases is that the administrative skills you bring to the table, the ability to provide supplemental and overflow communications. In this day and age, unless it's a truly catastrophic disaster, like say Hurricane Maria in Puerto Rico, or that Category 9 earthquake, if it ever happens out in the Pacific Northwest, is you're supplementing operational networks that are still in place by fire departments and police departments and the like. But that doesn't change the fact that you still need to communicate accurately.
Well, two things that I've constantly repeat to the members, especially when they're undergoing their basic training, is that one, you don't want to be a rescue Ricky. You do not want to be the person that walks into a shelter or an EOC or whatever with 3 HTs on your belt, squawking away, brightly colored vest, hat with all the badges on it, and I'm here to basically save the day. You don't want that. You want somebody who's cool, calm, and collected, but has skills, who knows what they're doing. And that dovetails with something that Vic Navarra, who was the start coordinator of the New York City Marathon for many, many years before he passed away from cancer from 9/11. He was a fire lieutenant. He always used the phrase semper gumby, always flexible. And nothing bugged him more than we're like minutes away from the starting gun going off the marathon and somebody's calling on the radio because they need toilet paper in one of the porta johns. It's like, you got to be flexible here. Some things will work themselves out. Don't worry about it. Just keep your mind on task of what's really important and get that information through as accurately and as quickly as you can. And he wasn't not even a ham. Like you said, he was a firefighter.
Right, right. Well, it's we had a guy who worked for the state Michigan Public Safety Communications Network, and I asked him one time. He was really He really got involved in the Section CW traffic net, and I asked him what attracted him to it, and he said, I liked the fact that they were just a group of quiet professionals, and I've never quite forgotten that term, quiet professional. That's what we want to be. We want to show up. We want to do our job. Yes, you don't want to look like. Does the webpage Ham Sexy still exist?
I'm sure it does somewhere, but I remember it very well, especially the picture of that red vehicle
Right,
with all those
right.
antennas on it.
Yeah, right, right. Yeah, that you don't want to be that guy. Uh, but we're kind of digressing, Charles. But yeah, yeah, points well taken though for sure. Yeah. Anybody else have comments or input?
Um, James, I would like to ask you to expand a little bit on the figure of the network management coordinator. What was the role? How does this particular amateur or operator handle that particular task?
Yeah. So when the under the National Response Plan, when we activate RRI for our major disaster, uh, we will identify a target station. So let's say it's W8ABC, located in Cleveland, Ohio, zip code 46205. And essentially, in the operating directive, everybody participating in RRI or NTS nets or the like, anybody using our network resources or the, sister nets in NTS are asked to originate what's called an operational readiness report, an OPRED message, and the format's defined in the National Response Plan. And essentially, the idea is that this standardized message format will then incorporate the information that will match the fields in a spreadsheet, and essentially just be a searchable spreadsheet of all the operators that are on the different nets, during the disaster operation. And you'll know, basically the message format asks, what HF nets are, what nets are you active on? What MCOM groups do you have connectivity to? What agencies, you have connectivity to? Do you have any operating limitations, like only enough gas in your generator to operate for another, 4 days or whatever? Just basic information so that we have an idea of who's out there. And so if I need to get a message to somebody in that area, in that disaster area, I know, okay, W7QLB, he's located in Tacoma, Washington, and he's got connectivity to, the city of Tacoma emergency management, such and such an Aries group, etc. And that's the idea that the sole job of the network management coordinator is to simply create that database in real time and keep it updated of the operators that are active on the networks to whom we can route messages, and that's really all it is.
So he's going to be the recipient of all those reports,
Yep.
and he's going to fix up that spreadsheet. So he's going to be the go guy to find out who's available and who's not.
That's correct. Yep. And that's his job to keep that up to date. The directive might say, please transmit an operational readiness report every 6 hours or every 12 hours or once a day or whatever, depending on the scope of the disaster. And then the network management coordinator will send out that spreadsheet as he updates it regularly so that everybody gets a copy of it, at least those that can receive it via WinLink or email or whatever the case might be.
Perfect. Appreciate it.
Yep, absolutely. Any other questions? Yeah, if you take a look at the National Response Plan, there's situational awareness reports format, and there's a standardized weather report format. And then of course the operational readiness report format. They're worth having a look at. So, okay, well, anything else before we close for the night?
Yeah, Jim, I got a quick question.
Yeah.
Do you have an update on when you're going to do the number 12 class with Steve?
Yeah, we're looking at probably doing it sometime in or maybe the either last week of February or the first week of March. That's
Okay,
kind of
thanks.
what we're looking at, right? We haven't actually set the date because it's just been such a zoo over here trying to get everything done.
Right. Yep. Okay. I'll pencil it in.
Okay, yep. We'll
Thanks a
send
lot.
out a notice well in advance.
You're good. Yeah. Great group tonight. Presentation. Thanks.
Yeah, thank you. Yeah, appreciate it, James.
Jim,
Yeah.
let me add to that.
Yeah, Bob.
Here we are. Okay. Let me add to that. Thank you for the presentation. This was not only professional, but it's something, this is being recorded. This is going to be available to the public or only within RRI. You have any plans for that? If I wanted to recommend people watch this, because I will. I'm the chairman of the ARRL Aries Committee for the nation, as you know, for this year. And this is exactly the kind of stuff we need. And if this can be made available, I'm going to promote it. That's up to you.
No, we post these periodically to a Radio Relay International YouTube channel. So I'll go ahead and post this here in the next couple of days and send you the link.
Okay, I figured you did. I just wanted to put that out there. I'm going to be recommending that this be watched by lots of people. Thank you, and great presentation.
Thanks, Bob. I appreciate that.
Jim, is the presentation going to be available on the site?
Yes. Mm-hmm.
Okay, great. Thanks.
Okay, and anybody else?
Hi, James. You hear me?
Yeah, Jorge, how are you?
How you doing, and the rest of the group? Listen, I totally agree what you were saying. Great, everything. That don't put all your eggs in one basket. Use what's available, and I agree. Just use one mold. We can use CW, whatever. I've done it in the past, and during the Hurricane Georges and Hurricane Maria and other disasters, along with working with shares and all that. So I totally agree. It's do the digital network, the DTN, and also CW. I believe that a lot in that. So it's great, And I don't know if there's something available here in Puerto Rico yet, but hopefully there is when we get together and then come with something. If not, we'll see what happens.
Yeah, well, we're here to support you. We've got some good projects we're working on, and our goal anyway is to help you guys be much better prepared come say late June, early July, when things might get interesting.
Oh, that's true. Yeah. Well, hopefully, where nothing comes this year, but you never know. Like an earthquake doesn't advise when it's coming, so there's no warning on that, basically.
Yeah, or extended
but-
power outages.
Oh, well, yeah, you experienced that, yeah, personally, and yeah, that's true.
Yeah, the 3-day power outage.
Yeah, that was good, but we'll see what we can do, and I appreciate your help and everything, James.
Yeah, thanks, Jorge. Appreciate your help. Yeah, absolutely. Well,
This
gentlemen.
is Eric.
Yeah, go ahead.
Can you hear me clearly?
I can.
With regard to the NIFOG, OXFOG, and the NRP, what are some key takeaways with regard to planning at the local and maybe the state level?
Yeah, so I think that the key takeaway for me is you need to understand really what it's a two-way thing. You need to understand what the expectations are for the agencies or organizations you work with, and the EC or whoever's performing the emergency communications resource management decisions for your group, be it an ARRL EC or RACI's office or COMEL or whatever. They need to be very upfront and honest about both the benefits and limitations of the amateur radio service. So to me, that's always the starting point. So for example, I might say something like this to a customer. Well, we have a high level of flexibility. We can often take communications to wherever it's needed. We're very survivable. We have all kinds of modes and methods available to us. But in exchange for that survivability and that reliability, we may not be able to do some of the things that you're kind of used to with, email and cellular telephones. And, so we need some brevity. We need very efficient message content. We may transmit it by voice, we may transmit it via data, but we need, brief, brevity and efficiency in the communications traffic that we convey. Be honest about your limitations. Don't overpromise, etc. I think that's one important thing at the local level to me. The other thing is to actually, you don't have to study it in depth, but take a look at the hazard and vulnerability analysis for your community. Both the formal one and maybe even conduct your own. So for example, one of the things that we did in advance of Cascadia Rising that really didn't have anything to do with ham radio, but we looked at the vulnerability of the public switch telephone network and the number of central officers in communities that were located along the ocean, that were within the impact zone. And you'd be surprised at how many there are, and the impact that would have on the internet and terrestrial communications facilities and the like. There's a lot of vulnerabilities out there, and I think it's important to understand that there are vulnerabilities. Nashville's a good example. I was in Nashville the day after that bomb went off outside the central office, and there was major disruptions to cellular data networks all over, Tennessee and even into parts of Kentucky and the like. And, things happen. And so understand, your hazards and vulnerabilities for your community. Understand, try and get a better handle on what agencies and organizations you may be supporting. But really, in my opinion, the most important thing is that, and this is where I think most MCOM groups fall short, is just that basic training in communications procedures. The ability to communicate effectively on a net, to convey information quickly and efficiently. And in one of our other courses, the basic radio telephone communications class, I use an analogy. Let's imagine I have a VHF repeater or a UHF repeater, and I've got 30 operators on that net, on that repeater, okay? So you got 30 operators in a net. Now let's imagine, just hypothetically speaking, that each of those operators has the same quantity of message traffic. They all have essentially the same amount of message traffic to process on that frequency. And it's all generally the same precedence, just hypothetically speaking. It's very easy to figure out that each of those operators gets only 2 minutes out of each hour to conduct their business. So think about that for a minute. You have 30 operators, all with roughly the same amount of important message traffic. That's 2 minutes per hour per operator. Okay. And how long does it take to transmit a message inefficiently? Okay, and so that's problem number one. Understand the incredibly scarce commodity of circuit capacity, particularly for voice nets on repeaters and things of that nature. Number two, most ARES groups or MCOM groups need to lose this idea that of concentrating their activity on a single repeater or frequency. You'll hear, for example, Red Cross traffic being handled on the same channel as, say, a hospital traffic or, emergency management traffic. Look at the available repeaters and resources in your community, and in your plan, decide which channel or which repeater, for example, or which system you want to use, for example, for hospital intra-communications, for which one you want to use for supporting the Salvation Army or the Red Cross, and try and subdivide your nets based on emergency management function. That's another, important takeaway, I think, at the local level. If you look at your county emergency plan, it's going to have alert and notification. It's going to have law enforcement, what law enforcement's supposed to do, what fire service is supposed to do, what DPW is supposed to do. Radio amateurs should be kind of the same. If we know that we're going to be supporting the Red Cross, assign a primary repeater for Red Cross, maybe a different repeater for just alert notification and for people to check in and get a deployment assignments. So you're not sharing the circuit capacity with that kind of mundane task. Have another one for supporting your local fire departments or whatever agencies you're supporting. Understand the scarcity of circuit capacity. And again, that a lot of management of circuit capacity comes down to the ability to communicate efficiently, and that's usually where hams fail the worst. You hear the thinking aloud, the long delays, because people can't use the phonetic alphabet correctly. You hear messages being repeated. The inability to use pro words that inculcate efficiency. For example, the pro word out is a wonderfully useful tool because it prevents an extra transmission. If I say WB8SIW, Roger number 223 out, that tells you I don't want to hear anything more from you. The frequency reverts back to net control. It saves the time lost when you come back and say, okay, well, thank you very much, back to net. And those little extra inefficiencies add up very rapidly over the course of an hour and eat up a lot of circuit capacity, and that kills a lot of nets. I guess those are some that just off the top of my head, just pop into the, kind of free thinking. Is that helpful?
Yes, that is helpful.
I mean, we're kind of enamored with the fact that we have these new digital modes, and I think that's wonderful. I'm a big proponent of developing digital capabilities, but let's be honest, a lot of our communications traffic still passes by voice methods. The other thing too that you can look at is what I call force multipliers. So RRI sponsors the Neighborhood Ham Watch or Neighborhood Radio Watch program. So let's imagine that you're supporting a search and rescue team. In the old days, when I first got involved in ham radio, well, maybe a little later than that, we were still modifying vacuum tube car phones and putting them in the trunk of our car. But in the old days, you would go ahead and shadow served agency officials. So if you had a search and rescue team operating in, say, a neighborhood, you would typically, each group, as they split up, you would assign a ham operator with each of those people. If you had 5 SAR teams operating, there would be 5 hams. Maybe a ham per person, or a ham for every squad, or 2 or 3 people that were outgoing door to door and doing the search and rescue process. In this day and age, with resources like GMRS and FRS and so forth, the radio club or the Aries group or the MCOM group can go ahead and train these organizations in effective voice communications procedures and how to properly operate on a net and efficiently handle their internal communications. And then all you need to do is provide one radio amateur to be the gateway between that organization and the Aries net, for example. So now you've got this force multiplier of GMRS radios and FRS radios that, used correctly, can provide pretty much all the internal communications within maybe a half mile or a mile or 5 miles, for an SAR team or an RSPCA group. I guess in America it's SPCA group or Humane Group or whatever kind of volunteer organizations active in disaster response. And you really only need to provide an amateur radio operator who's interoperable on their channel and also interoperable on the Aries frequency to the occasional message that may need to go to the EOC or outside the area. Well, then the amateur handles that. And so now you can use your human resources more efficiently. And that's a very scarce thing for the amateur and aging amateur radio community. Let's be honest, there aren't a lot of vigorous, 25-year-olds running around out there in the Aries world. Is that helpful?
He's muted.
Oh yeah. Eric, did that help you? Was that good information?
Yes, it's valuable insights.
Yeah. Okay, anybody else before we close for the night?
James, I wanted to say that I'm hoping I'm coming through on this. Covering the log and going over logging messages has been really helpful because I've been participating in being a target station for P2P on WinLink. And I have a lot of information coming in, and now I can practice putting that into some kind of a format. And so it gave me a perspective that I hadn't thought of before. It's something I hadn't really been exposed to in my Aries training, that I've participated in. So I wanted to thank you for that, because I think that's something that's really important, because when information comes in quickly, you have to be able to record it quickly and accurately. So I think that's been very helpful. Thank you.
Yeah, you're welcome, Patricia. Yeah, I think the ability to keep a good succinct radio log for your tactical communications is very valuable, as you mentioned. And this is also why radiograms have a message serial number, right? So for example, imagine yourself in an EOC or at an incident command post, and you have to, over a period of 8 hours, you originate 200 messages, and a message comes back to you in reference to one of those. You get a reply, or you get a service message that's undeliverable, or we can't locate the disaster official, etc. It's a lot easier if that reply message references your message number, right? Reference your message number 15, establishment of morgue at Cleveland Intermediate School approved by Michigan Department of Public Health. It's much easier than you trying to sort through a big pile of messages on your desk that, by date time group or just by subject or by any of these things. Message serial numbers are also very helpful. One of the reasons we promote the radiogram format, because it's part of that whole administrative process of having a message serial number for every message that leaves your message center or your EOC or your command post.
So when in your exercise, you were mentioning that there were thousands of messages. Did people print those out, or did they just have a digital copy? I mean, I'm trying to get a kind of a picture in my mind of how that actually worked. If a person was, receiving 200 messages in a day, what would that really look like? I mean, have they received them through WinLink, or did they receive them? And it didn't sound like there was a lot of voice, so it wasn't like a person had a clipboard and they were writing things out on the radiograms like we do on some of our nets when we practice. So how did that look?
Well, some of them were probably transcribed by hand, but I think most were transcribed, on word processors. And well, if it's a CW net, usually a word processor program, or I'll be honest with you, I have this thing here still in my shack. I don't know if you can see it, but it's the old Remington radio telegraph mill.
Oh, okay.
The old Army all capital radio operators typewriter. And
okay, right.
It's great for CW, and the batteries never go bad, and Windows doesn't update in the middle of receiving a message.
Oh yeah, especially 11. 11 going into
and I don't have to power it in a power outage either, because it's a manual typewriter. But seriously, it's really up to the operator. And what you find is if you're really active on traffic nets, all those skills become automatic. It's no
Oh,
big
okay.
deal over a period of some hours to handle a couple hundred messages. As a matter of fact, if you want to be a little bit entertained, you can see if you go to YouTube and you search holidays in the heart of the city telegraph operator, you'll see me sending telegrams from to North Pole, Alaska on a working landline telegraph circuit, Western Union type, telegraph circuit. And you'll see, clerks you have 2 or 3 clerks collecting messages and I'm sending them, and you can do 200 or 300 in a few hours in an evening, and it's no big deal,
Wow.
you know.
Okay. So
And
thanks.
it's kind of fun thing to see maybe, but again, it comes down to the skills, right? Just developing it so it all becomes automatic.
Right. Well, and I think that what's challenging is that when you're just practicing or training, learning, I mean, that could take hours. You could spend an hour a day focusing on just one thing. I mean, if you wanted to get better at a skill, but knowing what to do. I mean, we don't have a real active Aries group in our area right now. So the challenge there is making sure as an individual that I'm trained, so that's why your training helps so much. And there are people in my state that are helpful.
Yeah.
So just learning, what to do.
Yeah, that's why we try and encourage traffic handling, because even though they're just like routine radiograms most of the time, just kind of the skills of copying the messages and keeping the radio log and keeping track of them, it kind of becomes a natural skill after a while. Of course, nets aren't as active as they used to be. There's not as much traffic, unfortunately. But that's why we encourage it, is just because those are the administrative skills.
Well, luckily in Tennessee, we have 2 very active nets that are training and stuff. So I'm real pleased with that, but thankful for that too. So
Sure,
but
sure. Yeah. But
Okay, thank you.
it's like learning to play the piano. You start with 3 blind mice, and if you really work hard at it for enough years, maybe you can play Chopin's Revolutionary Etude.
Yeah, that'd be a few years practice there, definitely.
Yeah, about 30 years for me.
Yeah.
But, yeah, anyway,
Okay.
I'm not Podolsky or, Horowitz, but anyway, Patricia, thanks. Yeah, I hope that was a good answer for you.
It was. Thank you.
Yeah.
Thanks.
Okay, anybody else? We've hit the 2-hour mark, so maybe time for one more question and then we'll adjourn for the evening. The silence is deafening. Okay. I'd like to thank everybody for being here. You guys know where to find me. If you have any questions, feel free to reach out. And I guess this will conclude tonight's class, 73 to all. God bless. Have a great evening, and we'll see you at the next class. Thank
Okay,
you.
James. Good night.
Good night,
Jim.
Maureen.
Okay,
Yeah.
73, Jim.
73. See everybody soon.